Welcome to topic 4.1. In this topic, we will learn about the performance of a chiller plant, as well as what is a load profile, and how we're going to use a load profile to actually size our chillers. So, remember in topic 2, we have seen this BMS schematic. So in a BMS schematic, you'll be able to find a lot of different information inside. So all these are from the various sensors and various power meters located at the chiller plant. So a look at this kind of schematic, how do we know that our chiller plant is actually operating efficiently? So very important, you have to know what is the kilowatt per ton, okay, the chiller system efficiency that the chiller plant is currently operating at. So if you take a look over here, in this particular BMS, they actually do the calculation in the BMS itself. So inside this box, you will notice there's this particular values, 0.674. Okay, this value tells you the current system efficiency. That is 0.674 kilowatt per ton. So how do we know whether it's considered good or excellent, or whether you need to start to think of how to replace your chillers or do some retrofits? Okay, so if it's at the range of below 0.7, generally the chiller plant is operating at a very healthy range, and that's actually the requirement from that's actually one of the requirements. Okay, so any replacement projects, any new projects, it must be able to achieve at least 0.7. If not, there will be no point in doing the replacement exercise. Okay, so if the chiller plant, especially for those old buildings or old chillers, maybe 15 to 20 years, you may get efficiency as poor as 1.0 kilowatt per ton or 1.1 kilowatt per ton. That is when you seriously have to look into chiller replacement exercise. So chiller efficiency is not a constant value. So when we talk about the system efficiency in kilowatt per ton, this value is not constant. That is to say, just now the current operating efficiency is 0.674, doesn't mean that you'll remain at 0.674 throughout. So it largely depends on one very important factor, that is your percentage loading. What do we mean by percentage loading? For example, your chiller capacity is 500 ton. If your chiller capacity is 500 ton and is actually providing around 400 tons of cooling, that means your chiller is actually operating at 80% of its full load capacity. And if it's running at 200 tons only, okay, if it's operating at 200 tons only, it's actually operating at 40%. So when the percentage change, okay, it will affect your efficiency as well. Okay, so usually, okay, for centrifugal and reciprocating kind of chiller, the nearer it is to the full load, the better your chiller will be operating. Whereas for screw chiller and screw chiller, okay, if you are running at around 40 to 60%, it's actually you will hit the so-called the sweet spot, okay, the best efficiency. But usually chiller will not operate efficiently if you are running at very, very low load. For example, if you have a 500 ton chiller but you only use it to provide 50 tons of cooling, which is 10%, you'll be quite sure that this chiller will not be operating efficiently at this loading, at 10% loading. Okay, so that is the meaning of chiller efficiency is affected by the percentage loading. So for chiller spec sheets, okay, if you have this manufacturer data, I just want you all to concentrate on the inside the box, all the values inside the box over here. Okay, so for example, this chiller is a 560 ton chiller. Okay, when it's running at full load, it's 560 ton. So when it's at 100%, okay, if you look at the very first column, 100%, that means it's running at full load. the efficiency is around 0.493. Okay, what if you go and run at maybe 80%? That means you run it at 80% of the full load capacity. You will realize the efficiency actually improve. Okay, improve by a bit. So by a quick observation, what is the sweet spot of this particular chiller? Or which percentage loading will the chiller operate at its best efficiency? So if you just scan through the efficiency row, you will notice that at around 60%, okay, around 60%, it is operating at 0.445, which is the lowest among all the percentage loading. So you will try to buy this chiller and try to operate at around 60%. That will be the most ideal case. Okay, so that's how you are going to use this particular manufacturer data to help in your sizing and chiller schedule. So the other important term that you need to learn is called load profile. What is a load profile? A load profile tells you, right, how much cooling you need throughout the day. Okay, maybe over the 24 hours, how much cooling you are required to provide in order to cool down the building. Okay, so it is very important for selection and sizing of your chillers, because without knowing the load profile, you will not know what is the size of the chiller you are going to buy, or how long you should operate a particular chillers. Okay, so let's look at one example. Okay, a very typical load profile will look something like this. So your y-axis is your load, okay, and your x-axis will be the time. And usually the extreme left is at 0000 and extreme right is 2400. So this is 24 hours. So you see a typical load profile, right? Usually the off-peak will start from midnight and all the way until maybe morning, okay, 7 a.m. The load will be usually quite low. Okay, why is that so? Because nobody is at work. Okay, the sun is out. Sorry, the sun is not there. Okay, so the building is actually quite cool at this moment, and you don't have to provide a lot of cooling. And what happened when after around 7 to 8 a.m., that is when your people start to come to work, okay, and the sun start to rise, and your building start to get heated up very fast. Okay, so it will go from an off-peak state to a peak period. Okay, the peak state. So this peak period will stay for quite some time, maybe until the evening time when people start to go home. Okay, and maybe at night when people all start to leave the place. Okay, so usually the peak will be from the morning until the noon or afternoon. Okay, and during the evening it will start to drop gradually, and at night it will go to the off-peak state. So this is very typical load profile, maybe for an office building. But of course, different kind of buildings may have different kind of profile. For example, shopping centers. Shopping centers, usually the peak will be a bit later. Okay, because usually the shops and all the stores will open much later, maybe at 11 a.m. or 10 a.m. So the peak period may start a bit later, and the off-peak will also end a bit later, because usually your shops also will only close at 9 p.m. or 10 p.m. Okay, so different day, or maybe weekday and weekend may also be a bit different, because weekend nobody is working, so the load is usually much lower during the weekend. So that's a typical load profile. And the real thing, if you are going to use a BMS to trend the data, and after you trend the data using BMS and you go and plot it, it will look something like this. Okay, so of course there will be some spikes here and there, because sometimes the sensor may be affected, because if one reading is being affected, it will cause your load calculation to fluctuate a lot, and that usually happens during the startup of your chillers, and when you cut off your chiller, that period of time, there will be some spikes. Okay, and you may notice, why is there some load? Although at night, right, we know that the building is actually very cool and there's not much people working, but why is there a certain percentage of load there? It's because some of the facilities in a building is 24 hours operation, and also it requires cooling. For example, your FCC room, your server room, and this kind of critical area, you will need 24 hours cooling. And for that, you will have some minimum amount of cooling at this off-peak period. So if we know that if we are able to get our load profile out, okay, how are we going to size the chiller or select the correct chillers for the correct time? So for example, if you look over here, okay, during the off-peak period, it is operating at 200 ton, okay, and from morning onwards, okay, until afternoon is running at peak load of 100 tons, and during the evening it dropped to 400 ton, okay. So at these three particular phases, right, okay, these three particular period, which chiller should you operate if you have the following configuration? Let's say you have 3 big chiller, that means 3 500-ton chiller and 2 small chillers. Okay, so how are you going to operate it? So by observation, during the night time, which is 200 ton, it makes sense to operate your 200-ton chiller, your small chillers, and run it at 100% load. Okay, and during the daytime, okay, when it's at the peak period, you should go and run 2 big chillers. Okay, that means maybe your chiller 1 and chiller 2, such that it will provide enough capacity, okay, 1000 ton for the peak period. And during the evening time, okay, you may switch off 1 big chiller and run only one big chiller, which is 1 500-ton chiller at 80%. Because the load is 400 tons, your capacity is 500 tons, that's why you are running at 80%. So basically it should look something like this. So 2 big chiller in the day, then you off 1 big chiller during the evening, and at night you switch to the small chiller. So this may be your typical operating schedule for a day.